Okay, this problem says that I have a solution. I have 80 milliliters of sulfuric acid. That's going to combine with 0.424 grams of sodium carbonate, correct? So I'm going to form sodium what? The two there's the hint.
Sodium sulfate.
Sulfate, very good. So sodium sulfate, okay, plus the carbonic acid, which is going to break down to carbon dioxide and water, correct?
Yeah.
Very standard reaction. Now, let me make this sulfate a little bit better here. Okay? Now, in other words, they want to know the molarity of the solution. I have 80 milliliters of it. So, if I know the mass of sulfuric acid, can I convert that mass to moles? Yeah. So then I would know the moles in 80 milliliters, right? So couldn't I calculate, based on chapter 16, the molarity of that reaction, that quantity of sulfuric acid? In other words, the concentration of the acid. Okay, let's do that. So 1 mole of this is balanced. 1 mole of this is 98 grams. 1 mole of this is 106 grams. Okay, good. Now, so I'm simply going to be comparing this with this. I have this mass. I want to find this mass, correct? Am I doing this right? Okay, so I'm just going to say, H2SO4 over Na2CO3 equals what?
96 over 108.
96, did you say?
98.
98, that's okay.
0.9245.
And I'm looking for this mass here. So this is going to be X over what?
80. 0.4.
No, not 80.
0.424.
0.424. Andrew, what I'm trying to do is, I'm trying to find the mass of this that's going to be in that 80 milliliters. Because I want to know what is the concentration of that solution. Okay? So X is going to equal what? Come on, guys. 98 times 0.424 divided by 106, like 0.45? I mean, what is it? 0.392. 0.392?
Yeah. 0.392. Oh, I had 95. 0.392. Yeah, he's right. I did a typo.
Okay, so it's going to be 0.392. Right?
Yeah.
98 times 0.424 divided by 106 is 0.392 what?
Grams.
Grams, right? Now, I want to, how many mole, and that's going to be of H2SO4, right?
Yeah.
So what molarity does that represent? So no, I'm sorry, not what molarity, we haven't got there yet. What's the, convert that to moles. What's 1 mole? Isn't 1 mole 98 grams?
Yeah.
So what is 0.392 grams over
0.004.
98 equals what?
0.004.
X over
0.00 4 something, or
No.
exactly 4?
Yeah.
Really? Okay, good. Well, they're making it easy for us. Okay, let's not erase anything and just keep going. All right, so I have that many moles in that many milliliters, right? So, what do I do? So let me write that ratio, okay? So I have 0.004 over 80 milliliters. But what do I want to, I want to know the molarity of that reaction, right? Don't I want to know the molarity of that?
Yes.
So don't I want to know moles over 1,000 milliliters? Don't I?
Yeah.
So what is 0.004 times 1,000 divided by 80? 0.05. All right? So this value here is going to turn into 0.05 over 1,000 milliliters. So what's that called? What's the molarity? Which is equal to, what's the molarity? You can do this. You need a calculator?
5 times 10 to the negative 5.
No. Isn't molarity the number of moles per 1,000 milliliters? Not per 1 milliliter? You're dividing that through.
So it's 0.05.
Isn't it per liter? Isn't it moles per liter? Isn't that what molarity is? Yeah. We're in a learning, this is like a learning moment for us here. So isn't that true? So isn't it, yeah, do you see why I did that? I wanted to make sure that you understand what the unit labels actually mean. Do you see why I don't give any credit when you don't put the unit labels? I don't know if you even know what's going on unless you put the unit labels. It's a very good sign. Right? Or, I'm not going to read it, or I could put what? How else can I say that? Bracket, very good, Anna. I could put brackets. I can put brackets. 0.05 molar. You with me?
Yeah.
Everybody?
Yeah.
Chuckwood, yeah? Good. Let me make sure that's all on the camera. Oh, that looks good. Very good. All right. How many people have had it? We're ready to rock and roll. Ready to get out of here. We still got some time, but I'm done. Yeah. You get it? Okay. I still have to give you a paper.